That is the rule. I am multiplying by 2. And whenever you're multiplying, you are using a geometric sequence. And with geometric sequences, we have a common ratio. And again, we don't write the multiplication symbol because we know with all geometric sequences we are going to be multiplying. So I don't need that multiplication symbol. I just need the 2. Now we have 10, 5, 0, -5, -10. I look at that and I realize that those numbers are decreasing. 10 to 0, 0 to -10, we're going down on the number line. So if it's decreasing, remember from the other set of notes from the first page, if it is decreasing, we are going to add a negative number or we're going to have a fraction, depending on whether it's an arithmetic or geometric sequence. So let's look at this one, 10 to 5. I could subtract 5. Let's try it with the next one. 5 minus 5 is 0. 0 minus 5 is -5. So I found the answer and I am subtracting 5. And I know that will be an arithmetic sequence. An arithmetic sequence always has a common difference. Now here's the part where we have to pay attention very carefully. If you are subtracting a number, remember, we only add to arithmetic sequences. Our common difference should be addition. This is subtraction. We can use the additive inverse rule. Additive inverse to make this into plus -5. We're flipping and changing to make that plus -5. Remember, that's additive inverse. So when I have my common difference, I am not going to put just the 5. I'm going to put a -5 because that is what I'm adding. I'm adding -5. And on our last example, again, our numbers are decreasing. So either I'm going to be adding a negative number or I'm going to be multiplying by a fraction. Well, let's see what I've got here. 81 to 27 to 9. There is no adding and subtracting pattern, but I can figure out that if I divide by 3, then I'm going to have the pattern. So this is dividing by 3. So it's a geometric sequence. But just like this last problem, when we use geometric sequence, we don't divide. We actually have to multiply. So dividing by 3, remember when we did fractions and we did reciprocals, dividing by 3 is the same, and this is called the multiplicative inverse. So that we can actually multiply by 1/3. So we have a common ratio for geometric sequences, and we know we have to multiply. So we're not going to divide by 3. We're going to use the multiplicative inverse to change that to multiply by 1/3. So 1/3 becomes our common ratio. Okay, now when we have this much information, then we can write an expression to use for any part of our sequence. I could find out what the 5th term is. I could find out what the 10th term is if I have a variable expression that fits that sequence. So let's look at what a variable expression is. Well, a variable expression is an expression, which is a math phrase, which uses a variable in place of each term. So instead of saying, for instance, 2 plus 1, 3 plus 1, 4 plus 1, we're going to replace our numbers in our sequence with a variable so that it can work for any number in the sequence. And then we're going to add the common difference, or we're going to multiply the common ratio depending on which type of sequence we have. So let's use the same numbers since we already have all the information we need. We know that our first one was an arithmetic